Two sheets of 11 by 8 paper are placed on top of each other, forming an overlapping 8 by 8 square in the center as shown. The area of the rectangle WXYZ is. So 11 by 8. So this is 8 and this is 8. And then they're saying that the square is also 8. This is going to be 8. And this is 8. This is 8. And this is 8 from there to there. So since it was an 11 by 8, that means this has got to be 3. And that distance also has to be 3 since that represents part of the other piece of paper. So the dimensions of this look like 8 times 3 plus 8 plus 3, which is 14. And therefore the area would be 8 times 14. And 8 times 14 is 112. So number 19, the answer is B. In the regular pentagon, the measure of each interior angle is 108. If PQRST is a regular pentagon, then the measure of PRS is PRS. So we want this angle in here. Okay, so if this is going to be x, that's going to be x, because this is an isosceles triangle. That's what those lines mean. So that means if that internal angle is 108, which is what the question told me, 108 plus x is 180. So 2x will be equal to, what's that, 72? And therefore x is 36. So now this angle, PRS, will be equal to that angle, which is 108, minus x. So PRS, that angle, will be equal to the internal angle, which is 108, minus x. So that's 108 minus 36, and that is 72. Number 12, the answer is A. A cube has 6 faces and 12 edges. How many vertices does a cube have? Well, let's count the vertices. 1, 2, 3, 4, 5, 6, 7, and 8. So number 11, the answer is E. A circle is drawn so that no part of it lies outside a regular hexagon. If such a circle does not touch all 6 sides of the hexagon, what is the maximum number of sides that it could touch? So first, let's draw a hexagon, a regular hexagon. So here we go. Here's a regular hexagon. Now let's talk about this question. The first thing they tell you is that the circle that is drawn inside, no part of it lies outside of it, right? So here's one example. No part of this circle lies outside the hexagon. Now, how many of the sides does this circle touch? Well, 0, okay? But 0 is not one of our answer choices, but I just wanted to show you that. How about if I draw a circle like this? It touches one of the sides, and therefore 1 is possible. But let's see if we can get any others. How about if you draw a circle that touches 2 sides? Is that possible? And the answer is yes. Here's an example of that. It touches 2 sides. So 2 is also possible as an answer. Okay, well, the maximum number of sides is what we're looking for. So far we've got 2. Can we get more? Can we get a situation where a circle drawn touches 3 sides and only 3 sides? And the answer to that question is no. If a circle touches 3 sides, it will touch the other 3 sides also. So, since if you have a circle that touches 3 sides of the regular hexagon, it will touch all 6 sides, the maximum is just 2. That's the only way that you can get a circle inside a hexagon touching the sides. You can either get 0 sides that it touches, 1 side that it touches, or 2 sides. Once you get to 3, it touches all 6 sides, and they tell you in the question that the circle does not touch all 6 sides. So the maximum we can get is 2. In the diagram, square PQRS has side length 2. Points M and N are the midpoints of SR and RQ respectively. What is cos of MPN? Well, on the Canadian exams, you're allowed to use a calculator. So let's use a calculator. Why not? Side length 2, if M is the midpoint, SM would be 1. So this angle in here I'll call theta. So using the tan of theta, it would be 1 over 2. Use your calculator and you will get theta equal to 26.565. Now because of the symmetry of this diagram, that's 2 and that's 1. Therefore this is theta also. So therefore this angle in here, we can just call it, well, it's MPN. Angle MPN is really 90 minus 2 theta. And since we know theta, we can calculate that. It will be 36.87. And then now you just take your calculator and calculate 36.87 cos, and when you do, you get 0.8. And that's 4 over 5. So 17, the answer is A. PQRS is a square with side length 60 and center C. Point W lies on PS, so that WS is 53. Point X lies on SR, so that XR is 40. The midpoint of QR is W. Point Z lies on PQ. What is the length of ZQ so that the total area of the shaded regions is equal to the total area of the non-shaded regions? Well, let's split this up into a couple of regions here. I'll do that line, and I think drawing that line would be sufficient. And here we go. So ZQ I'll just call X. Now they're telling me that the shaded area is equal to the unshaded area, so that means the shaded area must have a volume half that of the square. So the square is 60 times 60, so half of that. And that is, what is that? 1800? Yeah. All right, so now let's figure out the formulas. We're going to need some dimensions here. This they give me is 53, this is 40, so this is 20. And then C is the center, and that's very important because that's going to help us a lot. Since C is the center, we can essentially just split it down the middle and we'll get 60 divided by 2 for those half sides, I guess. So that means from here to here is 30, from here to here is 30, from here to here is 30, and so on. So let's see what we can do here. 1800. Well, if I use this triangle first, 1/2 base times height, 1/2 x times 30. Let's see, what can I do next? I'll just do this one. That's going to be 1/2 base is 30, and the height is also 30. And then this triangle right here, 1/2 base, which is 20, times the height, which is 30, and then 1/2 this triangle, 53 times 30. So that means 1800 is equal to 15x plus 450 there, plus 300, and then plus 53 times 30 divided by 2, 795. All right, so now put everything on one side. You get 255 is equal to 15x, and therefore x is equal to 17. So number 20, the answer is E. Quadrilateral is bound by the lines x equals 0, x equals 4, y equals x minus 2, and y equals x plus 3. The area of the quadrilateral is. We will need a diagram, so let's draw a diagram. And it doesn't have to be a work of art, but let's just draw these. So x equals 0 is basically just the y-axis. So this is the y-axis, but it's also x equals 0. X equals 4, well, we can call this 4, and then a line right through it would be x equals 4. So let's draw a line right through it. And then y is equal to x minus 2. I can just plot 2 points really quickly. When x is 0, y is negative 2. And then when x is 2, y is 0. So those 2 points, that would connect to form that equation. And this one, y is equal to x plus 3. Again, plot 2 points really quickly. When x is 0, y is going to be 3, so approximately here. And when x is negative 3, which is about here, y will be 0. So connect those two. So there we go. The quadrilateral obviously is this guy right here. And we have to figure out the area of that. Okay, area of a quadrilateral is basically base times height. So I just have to figure out some distances. The first distance is going to be the base, and that should be relatively simple since we know those points. This point right here, that one is 4 and 2. And this point right here, well, that is 0 and negative 2. So using the distance formula, we can easily figure out that distance. So that's a base. 4 minus 0 squared plus 2 minus 2 squared, and the square root. So that's what, 16 plus 16. So that's 4 root 2. Yeah, root 32 basically. Okay, well, let's keep going here. Now we have to find the height. The height is not as simple. We have to do a little bit of more math here. So the height's going to be the perpendicular distance from any point down to the base like that, where that's a right angle. So we're going to need the equation of that line, this line right here. Shouldn't be a problem. Y is equal to mx plus b. Now this line is perpendicular to this line, right? And this line here has, what is it? Y equals x minus 2. Yeah, so that has a slope of 1. So the line that's perpendicular has a negative reciprocal as a slope, which would be negative 1. So immediately we know that m is negative 1. And then b I can get by substituting any point. So let's just substitute that point, which would be, what's that point? 0 and 3, because that's on this line right here. So when y is 0, we have b. So b is 3. Okay, so that equation is y is equal to minus x plus 3. All right. So now we have to figure out the intersection of that line with this line. That line was minus x plus 3, and the other line is x minus 2. So minus x plus 3 is equal to x minus 2, so that means 5 is equal to 2x, and therefore x is equal to 2.5, because 5 divided by 2. And substitute that into either of these, and when you do, y would be a half, 0.5. So that means this point right here is 2.5 and 0.5. So now we can easily figure out h. That is this distance right here, that red line. So h is going to be 2.5 minus 0 all squared plus 0.5 minus 3 all squared. And that's going to be under the square root sign, so that's going to be 2.5 squared plus 2.5 squared. So that is 2 times 2.5 squared, so 5 over 2 squared like this under the square root. So it's really 25 over 2 square root, which is 5 over root 2. Okay, so now we come back here to the very beginning. Base times height. The base was right here, 4 root 2, and then the height we just figured out was 5 over root 2. And therefore the root 2's cancel, and I just get 4 times 5, which is 20. And therefore number 18, the answer is E. In the diagram, the side lengths of the 4 squares are shown. The area of the 5th square is k. What is the value of k? All right. So if these are all squares, yeah. So let's see here. If this is 1, then that means this must be 1. That distance from here to here. And therefore the distance from there to there will be 3 minus 1. So this distance here is 2. This distance is 8, and this distance is 4. Therefore, this distance from here to here will be 4. So that means the side length of that square that has the k inside of it is 6. So the area is 6 times 6, and that is equal to k. Therefore, k is 36. So number 15, the answer is C. In the diagram, square PQRS has a side length of 40. Points J, K, L, M are on the sides of PQRS as shown, so that JQ equals KR equals LS equals MP equals 10. Line segments JZ, KW, LX, and MY are drawn parallel to the diagonals of the square so that W is on JZ, X is on KW, Y is on LX, and Z is on MY. What is the area of quadrilateral WXYZ? Okay. So let's draw some lines here, and I think those lines will help us. The first is going to be a cross like this. So like that. And the second one is going to be a cross like that. And then I'll draw one line sort of top to bottom like this. Okay, so here we go. 40 is the side length, and 10 is the lengths of these guys, these little guys. So that means this would be 30. And in a very similar way, that's 10 and that's 30. That's 10 and that's 30. That's 10 and that's 30, like that. Okay. So that means if top to bottom is 40, side length is 40, and this is 10, right? It's the same as that. That's 10. And same thing, that's 10, same as this. Then that means that this in the middle would be 40 minus 10 minus 10, which is 20. And then the side length of this shape, which I'm confident is a square, because these are going to be right angles, since it tells you in the question that this is parallel to the diagonal of the big square. Then that's going to be right angles, and because of the symmetry of this diagram, this side will be the same as that side. So that's essentially a square. So I'll just call it having x as its side length. So in this triangle, if you look at it, you have a Pythagorean relationship. X squared plus x squared is equal to 20 squared. So 2x squared is equal to 400. X squared is equal to 200. And x squared represents the area of that square. So number 20, the answer is B. In the diagram, PQR is a pentagon. PQ is 8, QR is 2, R is 13, ST is 13, TP is 8. Also, TPQ and PQR are 90 degrees. What is the area of the pentagon? We will break up this pentagon into a few sections. So the first one, this guy right here, that rectangle, then this triangle, and then of course the other triangle. And I will draw one more line that is going to hit there at a right angle like this. Okay, and now at this point I think it should be fairly straightforward to figure out the area. So this is an 8 by 2 rectangle right here, so that area obviously will be 16. This is, well, from here to here is 8, and from here to here is 8 minus 2, which is 6. So that is 1/2 base times height, 1/2 8 times 6, so that is 24. So put that 24 right there. And then now, using Pythagoras, I can get the distance of TR. TR squared is just 6 squared plus 8 squared. So that's what, 100? So TR is 10? So let's just put that 10 right here, 10. So this, therefore, is going to be 5, since that is an isosceles triangle, and the height would cut that side in half. So this would be 5. And now I can get the height, if I just call it h for height. H squared plus 5 squared is equal to 13 squared. So h is equal to 169 minus 25, h squared that is, and that's 144. So therefore, h is equal to 12. All right, h equals 12. Okay, so the area of that triangle, this one right here, that can be calculated again, 1/2 base times height. The base is 10, since that was 10, and the height I just got is 12. So that's going to be 60. So this is 60. So the total looks like this 16, total area I should say, plus that 24, plus that 60, and that is equal to 100. And therefore number 20, the answer is D.